In this video, we're going to go over 6D in the Unit 3 packet. Formulate is solving absolute value equations and inequalities. In this video, we'll go over both the notes and select practice problems for 6D. 6D, the objective is to formulate absolute value linear equations. Throughout this video, if you're watching this in class, make sure to pause the video and ask me any questions over this as well. Okay, let's go ahead and do the 6D notes. Formulate absolute value equations and inequalities. So, we're given the inequality notation. -7 is less than x is less than 2. The interval notation of that would be open parentheses, -7, comma, 2, open parentheses. They're both open because there's no lines underneath these inequality symbols. For the number line, we'll draw the line. Both of the points are open holes because, again, there's no line under the inequality symbols. And the x is in the middle, so that's where we're going to shade in the middle of these two critical points. Now, to find the absolute value inequality that goes with this, we want to find the midpoint first. To find the midpoint, we're going to add the two endpoints together and divide by 2 because there's two things here. So we have 2 minus 7 all over 2. That's going to give you -5 over 2. And that's going to be -2.5. That's our midpoint. The other number that we want is the distance. The distance between the midpoint and either one of the endpoints. So to get that, we'll take the endpoint minus the midpoint. So we have 2 minus -2.5. Since we have two negatives, they multiply together to give you a positive. So the distance is positive 4.5. Again, distance is always going to be a positive number. So then we'll write our absolute value inequality. We have the absolute value of x minus -2.5, which would be a plus 2.5, is less than our distance, 4.5. Again, remember to pause the video if you have any questions over this, for those of you in class today. Let's look at the next example. 1 is less than or equal to w, less than or equal to 4. Our interval notation, we would have 1, 4, and then since there's lines underneath the less than symbols, we'll put brackets around it. We'll draw our number line, and then we'll put points instead of holes since there are lines under the less than signs. W is in between the two numbers, so we're going to shade in the middle. To find our absolute value inequality, we will find our midpoint and find the distance. So again, to find our midpoint, we're going to add the two endpoints together and then divide by 2 because there's two things. 4 plus 1 is 5. 5 divided by 2 is 2.5. So that's our midpoint. To find the distance, we'll subtract 4 minus our midpoint, 2.5. And that's going to give you 1.5. So we'll go ahead and write our absolute value inequality from this. So we have the absolute value of w minus 2.5 is less than or equal to our distance, 1.5. Let's look at the next one. We have x is less than -3 or x is greater than 8. Before we write our intervals, let's go ahead and draw the number line. So these are going to both be holes. Notice there's an or right here. Whenever there's or, we're going to shade on the outside instead of the inside, because we have two different pieces. Since we have two pieces, we're going to have two intervals as well. Notice this arrow pointing to the left forever, that's going to be a negative infinity. The arrow pointing to the right forever will be a positive infinity. So we'll write our two intervals. We have negative infinity to -3 with parentheses, and then we also have from 8 to infinity. Instead of writing or in interval notation, we'll write a U instead. U stands for union. It's the notation you would use in place of or for inequality notation. To get our absolute value inequality, we want to find our midpoint and the distance again. To find the midpoint, add the two numbers together, the two critical points, divide by 2. So 8 plus -3 over 2. That's going to be 5 over 2. That equals 2.5 again. To find the distance, again, subtract the endpoint. So 8 minus 2.5. That's 5.5. So we can write our absolute value inequality. Absolute value of x minus 2.5 is greater than our distance, 5.5. Now we put greater than right here because it's an or. We would put less than for and when the variable's in the middle. Let's look at the last example in this table. T is less than or equal to -9, or t is greater than or equal to -1. Let's draw our number line. For both -9 and -1, they are closed points. They have lines under the inequality symbols. It's an or, so we're going to shade on the outside. Now we'll draw our two intervals. Remember, it's going to start with negative infinity and end with positive infinity. So our first interval would be negative infinity, comma -9. It's a closed point, so we're going to put a bracket. U for the or for union, bracket -1 to positive infinity. Infinity and negative infinity will always have parentheses, since they're not actually included. Okay, let's find the midpoint, add the two numbers together, and then divide by 2 because there's two parts. So we have -10 over 2, that equals -5. So our midpoint is -5. To find the distance, we subtract the larger endpoint from the midpoint. These two negatives multiplied together is a positive, so it's like 5 minus 1. That's 4. So 4 is our distance. Now we can write our absolute value inequality. The absolute value of t plus 5 is greater than or equal to our distance 4. Okay, let's apply that to a word problem. H2O is in a liquid state whenever it's between 32 and 212 degrees Fahrenheit. Write an absolute value inequality that represents the temperatures when water is not a liquid. So we want to find our midpoint, our distance, and list our critical points. We already have our critical points. It's 32 and 212. The meaning is when H2O is ice and when it is steam. The boiling and melting points. So we could go ahead and draw that on our number line. We have 32 and we have 212. It says when it's not a liquid, so we're going to shade the outside. So we have ice right here, we have water, and then we have steam. To find the midpoint, we'll add the two critical points together and divide by 2. So 212 plus 32 divided by 2. Half of 244 is 122. That's our midpoint. To find our distance, we're going to take the difference between our higher critical point and our midpoint. So 212 minus 30 minus 122 is 90. So our distance is 90. So we'll use that to write our inequality. The absolute value of our temperature minus our midpoint, 122, is greater than or equal to our distance, 90. It has a greater than sign because we're shading the outside. When the outside is shaded, the absolute value part will always be larger. We shade the inside, the absolute value side will always be smaller. So here's the equation. We have tolerance equals the absolute value of the variable minus the midpoint. Here's our diagram of this. Again, you'll shade the line based on these things right here. So if we have x minus m is less than the tolerance, we'll shade the inside. If we have the absolute value of x minus m is greater than the tolerance, we'll shade the outside. And this is what the inequalities would look like if they wrote them in the reverse order, with the variable by itself, or the constant by itself, is on the left side, and the absolute value expression would be on the right side. Let's look at the next page of the 60 notes. Write the absolute function in the form f of x equals a times the absolute value of x minus h plus k given each graph. So looking at the graph on the right, we can see that this is a minimum value. It's a low vertex. The extrema is min. And that means that our a will be positive. Our slope, look at another lattice point on the right side, and then do our rise over run. Our rise is 2, our run is 1. So we have 2 over 1. It will be a positive 2 because, again, a is positive. And their vertex is this coordinate point right here. So we have -3 and then 1. -3, 1. So from that we could determine what A, H, and K are. A will be +2, H is -3, and K is 1. So then we'll just plug these into the formula right here. So our function will be f of x equals 2 times the absolute value of x minus h, which is -3, plus 1. Simplify, these two negatives multiply together, give you a positive. So our function is f of x equals 2 times the absolute value of x plus 3 plus 1. So looking at this vertex right here, notice it's a maximum, it's a high vertex. That's our extreme is a maximum. Since it's a maximum, A is a negative number. It was reflected across the x-axis. We'll take another lattice point on the right side here. Our rise is 1, our run is 2. So our slope is going to be 1/2. It's a -1/2 because A is negative. So A is going to equal -1/2. Our vertex is -2, 1. That's our coordinate point for the vertex. So that means that H is -2 and K is 1. So our function will be f of x equals -1/2 times the absolute value of x minus -2 plus 1. Simplify, the two negatives multiply together as a positive. So our final function is f of x equals 1/2 absolute value of x plus 2 plus 1. Let's look at the last example on this page. Find the vertex. It's a low vertex, that's a minimum. Since it's a minimum, A is going to be positive. Find another lattice point besides the vertex. Do your rise over your run. Your rise is 1, 2, 3, and your run is 2. So your slope is 3/2. A will be a positive 3/2. Our vertex coordinate point is -1, -3. So our H is -1 and our K is a -3. So our function will be f of x equals +3/2 times the absolute value of x minus -1 plus -3. And then we'll rewrite that after simplifying the operation signs. We have f of x equals 3/2 times the absolute value of x plus 1 minus 3. Now let's do some select practice problems from each of the level 60 worksheets. Let's start with the level 1 worksheet. We'll work on number 2. Henry spends $90 on lunch and spends $16 on bananas. Hicks spends $120 on clothes. Henry borrowed money from Hicks to buy his items. In other words, Hicks paid for Henry. Hicks has a bank account with a balance of $250. How much will the purchase cost him? What would Hicks' bank balance be after all the debts were paid? So let's break this down. So Hicks paid for all three of these things. He paid for the $90 for the lunch, the $16 for the bananas, and the $120 for the clothes. And then he started with $250. So basically you would have 250 minus each of these added together. 90 plus 16 plus 120. To find the answer to the first question, you combine all three of these numbers, which would be $226. Okay, and then you'd have 250 minus 226. So he would have $24 left over. So it would cost him $226, and he would have $24 left over. Let's look at number 10. Daniels goes to the shopping center. He has a bank account with a balance of $259. Daniels paid $45 for a cell phone with her credit card. She also spends $150 on an iPod and $100 for a taxi. What would Daniels' bank balance be after all debts were paid? So to get the answer for this one, we would take the original amount, $259, and then subtract it from the total cost of all the money that Daniels spent. $45 for the cell phone, $150 on the iPod, and then $100 for the taxi. So after that, you would get $295, and then subtract that from $259, and that would make Daniels $36 in debt. Let's look at the level 2 and 3 worksheet for 6D. You'll find the vertex, see if it opens up or down, if it has a max or a min and what it is, if it's narrower, wider, or the same as the parent function, f of x equals the absolute value of x. Okay, let's look at number 2. The vertex would be our h, comma, our k. Our h is the opposite of what's in here, so it would be a +3. Our k is the same thing as the outside, it's -4. Since a is positive, it will open upwards. And it will have a graph that looks like this. It's right side up v. So that means it has a minimum. The minimum would be at whatever your k value is. Y equals -4. And if we look at this number at the front, 7 is larger than 1. So that would be a vertical stretch. Vertical stretches are more narrow. Vertical shrinks would be wider. Let's look at number 5. Y equals 3/4 times the absolute value of x plus 3 minus 6. Our vertex h, k would be -3, -6. It's -3 because it gets the opposite of what's in the inside. It's what gets you 0 for x. -3 plus 3 would give you 0. A is positive, so it's going to open up. Your graph will look like this. You'll have a minimum. Your minimum value is at y equals -6. Since 3/4 is smaller than 1, it will be wider. It's a vertical shrink, a vertical compression. Let's look at number 9. Neatly graph each absolute value function. So if we look at this negative right here, that means there's a reflection across the x-axis. The +3 means that it goes left 3. And then the +5 means it goes up 5. And this is all from the origin. So we'll count left 3, 1, 2, 3, up 5, 1, 2, 3, 4, 5. It's going to open downwards because it reflected across the x-axis. And then we would sketch our graph. Also, the vertex would be -3, 5. That's our point right here. And their slope would be +1 and -1. Let's look at number 12. Our vertex for this one would be 3, 2. We could plot that on the graph. It's negative, so it's going to be opening downwards. And our slope is 3/2. 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. And then just draw your lines. So from the last unit, you mostly used transformations to draw these graphs. Now you could also draw the graphs by using the vertex and the slope. Again, it opens upward if it's positive here, opens downwards if it's negative in the front. On the next page, let's look at number 14. Write the equation of the graph, then give its range as an inequality. So our equation, let's find the vertex. It's -3, -2. Our slope right here looks like it's a 1. And A will be -1 since it's opening downwards. So we'll use that same function on the front page. F of x equals A times the absolute value of x minus h plus k to write our equation. So we have f of x equals A, which is -1, times the absolute value of x minus h. So it would be x minus -3, which would be a +3, minus 2. Our range is lowest y to highest y. Our lowest y is going down further, so it's -infinity. Our highest y would be -2. Y is less than or equal to -2. And if you were to write that interval notation, it would be -infinity to -2, bracket. Let's look at the last question on this page, number 19. The number of boats a boat dealer sells each month of the year from March to December can be modeled by the function b equals -15 times the absolute value of t minus 5 plus 120, where t is the time in months and t equals 1 represents January. A. Complete the table of values that graph the function. So we're just going to plug these numbers in for t and evaluate to get b. So we can write the first one right here. And you can also put this in the calculator. So we have -15 times the absolute value of -2 plus 120. That'd be -15 times 2 plus 120. So it equals 90. So boats sold when there are 3 months would be 90. So we would plot that point on the graph. So we have 3 months and 90 boats sold. We would continue this for the other points on the table. You could also put this graph, this expression into Desmos. So we could type negative 15 times the absolute value of t minus 5 plus 120. And we could add a slider for t. So if t was 5, b would be 120. Replace 5 with 7. That would be 90 again. Replace 7 with the next number, 9. 60. 11. That would be 30. And then 12, you'd have 15. So we can fill in our table with those found numbers. Notice it's symmetrical right here. That would make this the vertex for this absolute value equation. Let's go ahead and plot the points for the rest of these. Looking at B, it says, what is the maximum number of sales in 1 month? So to look at this would be talking about the vertex. The maximum number of sales was 120 boats sold. The month that was 5. The minimum number of sales in 1 month would be the last one, the 12th month. And that was only 15 sales. Since this is a real-world problem, that's why the reasonable domain would stop here. If we were to use that for a prediction, we would go along this line. Alright, let's look at the 60 Level 4 worksheet. Number 3. The mean distance of the Earth from the Sun is 93 million miles. The distance varies by 1.6 million miles. What are the maximum and minimum distances of the Earth from the Sun? The first thing you want to do is formulate your absolute value equation. So the mean distance is the midpoint. The distance varies would be your tolerance, your distance. From the notes from before, remember we have the absolute value of x minus the midpoint equals the distance, the tolerance. So we're going to have x minus 93 equals 1.6. To find the maximum and minimum distances, we're going to break up the absolute value into our two pieces, our negative piece and our positive piece. Our negative piece would be x minus 93 equals negative 1.6. And our positive piece would be x minus 93 equals positive 1.6. From there we'll solve each equation. Let's solve for the minimum first. Add 93 to each side. You get x equals 91.4. And then we'll solve our positive piece for the maximum. add 93 to each side. X equals 94.6. So this is your minimum, 91.4 million miles. Our maximum is 94.6 million miles. Basically, you're just adding or subtracting from the 93 million miles to get that. Now let's look at one more from this page. Let's look at number 9. The coldest temperature recorded the past 200 years is negative 126 degrees Fahrenheit in Antarctica, and the hottest temperature recorded the past 200 years is 134 degrees Fahrenheit in California. Write an absolute value inequality to model in the form absolute value of T minus M is less than or equal to A, where T is the variable in degrees Fahrenheit, M is the average temperature, and A is the absolute deviation, also known as tolerance and margin. So they give you the two extremes, and they want you to formulate the midpoint and the distance. So first, let's draw our number line and plot the two extremes. We have negative 126, and then we have 134. It's in between, so we want to find the midpoint first. So we have 134 plus negative 126, and then we're going to divide by 2. And that would be 8 over 2, which equals 4. So our midpoint is a positive 4 degrees Fahrenheit. To find the distance, we just subtract these two numbers. 134 minus 4 will give you a distance of 130 degrees Fahrenheit. So our formula would be we'd plug in 4 for M, and we plug in 130 for A. So our inequality would be the absolute value of T minus 4 is less than or equal to 130. Remember, in this packet there is a key on the last few pages of it. Remember though, to get the credit though, you need to show the steps, don't just copy down the answers. Also on Canvas, be sure to do your cherry quizzes and checkup quizzes as you go along in this packet. So now you should do the quizzes related to 6D. Do the cherry quiz before next class, and then we'll start with the checkup quiz for 6D next time.